In this video, we're going to review for test number 1, which includes the content for attributable functions and transformation of the parent functions. So on this graph, what is the domain? So we know to look for the domain, we're going to look for the boundaries on the left and the right side of the graph. So look at the entire graph. This is the very left side, and you see a circle, so your picture stops here. So on the left side, this is a boundary here, and is touching -8 on the number line. And on the right side of the picture, this is the right side of the picture, and you see the arrow. It means your picture keeps going to the right side without ending. So on the right side, your boundary is way over there for no ending. And how do we represent no ending? We know it is infinity. Is it positive or negative infinity? Look at your boundary and see where it touches the number line. It touches the number line here, and the numbers on this part of the number line are 6, +6, +8, +10 until positive infinity. So the domain is from -8 to positive infinity. Okay, next one. Range. Range is the boundaries from the top and the bottom. So on your picture, you're gonna draw this kind of two boundaries. Okay? So we see this is lower than this. So on the entire picture, this is the top of the picture. So you're going to draw a boundary line on the top of the graph, and it hit +8 on the number line. So that is the top limit, top boundary. Okay? And for the bottom boundary, be careful. It seems that this is the bottom of the graph. However, look at your entire picture. We see the arrow, so we know the picture keeps going down. And we know on the bottom, if you see the arrow, it means on the bottom, the boundary bar falls to no limitation or infinity. Okay? The arrow tells you infinity. Is it positive or negative infinity? Look at your boundary bar. Your boundary bar is touching the number line here, and the numbers are the number lines are -4, -6, -8 until negative infinity. So the boundaries on the top and the bottom is from negative infinity to +8. Okay, next one. Increasing interval is from where to where your picture is increasing. Okay, so first look for the growing up part of the graph. How are you going to look for that? You're going to draw the picture from the very left. Draw the picture and follow your pencil to see if it is going up or down. You see from the beginning until here, my pencil is going up. So this part of the graph is increasing. Let's keep looking at the entire graph first. Okay? And you see, keep drawing it from here to here. You see my pencil is going down. So this part of the graph is decreasing. We're looking for increasing, so we don't look at this part. Okay? And keep drawing your picture from here to here. You see my pencil is going up. So this part of the graph is increasing. And keep looking from here until the end. My pencil is going down, so this part of the graph is decreasing. We're not looking at it. So you see the entire graph, you have two increasing part on the picture. So you're going to have two increasing intervals. So now you're going to draw a boundary bar from left to the right for each part of the increasing graph. So for the first part, this is the left side. So you're going to draw a boundary here. And it touches -8 on the number line. And for this part of the increasing graph, this is the very right side. So draw a boundary bar here. And it's touching the number line on -4. So the boundaries for this part of the increasing picture is from -8 to -4. And look at the second part of the increasing picture. It starts increasing here. So this is one boundary on the left side. And for this part of the increasing picture, it stops increasing here. So this is a right side boundary. And the two boundary numbers are from 2 to 8. It means in this area from -8 to -4 is where my graph increasing. And from this area 2 to 8 is where my picture is increasing on the other side. Okay. Decreasing interval. We just see on the entire graph we have two decreasing parts. This part and this part are decreasing. So now you're gonna give me the boundary on the left and the right side for each part of the decreasing picture. Okay? So for this decreasing part of the graph, this is a left side boundary, and this is a right side boundary. So the boundary numbers are -4 to 2. So this part of the decreasing graph is inside of the interval -4 to 2. Now, second part of the decreasing interval. This is the left side. And on the right side, be careful. This is the right side of the graph. And you see the arrow, you know the graph keeps going to the right side. So on the right side, the boundary is way over there to infinity. Is it positive or negative infinity? The boundary bar is touching the number line here, and the numbers are +10, positive infinity. So from 8 to positive infinity is the second part of the graph that is decreasing. So it is from 8 to positive infinity. Okay. Next one. Is the graph increasing or decreasing in the interval? So now we look for the boundaries, we look for the intervals first. Okay? From 3 to 6 on the x-axis, look for these two numbers. 3 is here, 6 is here. So we're going to draw the boundaries based on these boundary numbers. And it cut this part of the graph. So now you're going to decide, is this part of the graph going up or down? So draw it from the left to the right. You see my pencil is going up. So this part of the graph is increasing. That's your answer. Okay. Next one. F parenthesis -5 equals what? It means when x equals -5, y equals what? So on x-axis, look for the number -5. It is here. Between -4 and -6 is where -5 is. Okay? And then you find this number -5 and mark it. Then extending your mark to touch the graph. It touches here. So we're talking about this point on the graph. So now tell me what is the y value of this point. So start from this point, go to touch your y-axis. It touches at 4. So your answer is 4. Next one. F of -6.5. It means when x equals -6.5. So on x-axis, look for the number. -6 is here. -7 is here. -6.5 is between -7 and -7, which is here. So this is -6.5. Now we find this number. Let's extending your mark to touch the graph, and you'll see what? You'll see your mark is on the graph. So we're talking about this point on the graph. So what is the y value of this point? From this point, go to touch the y-axis. It touches here at the origin, which is 0. So your answer is 0. Okay? Next one, transformation. Okay. So what is the transformation of this equation? Okay. So first you know this is a complicated equation with numbers in it. And based on this complicated equation, you're going to tell me what is the most basic parent equation here. So parent equation comes from this baby equation. So what is the most basic part in the baby equation? We see the basic part is x squared. So the most basic part is y equals x squared. So now you have two equations, the baby equation and the parent equation. Put both of them in the decimals graphing calculator and look for the change on the graph. So now let's go to the decimals. So I'm gonna look for it. So I put in searching for decimals. And you see the first one, decimals graphing 2. Let's do graphing calculator. Yeah. Okay. Now in the left side, we're gonna put the two equations in. The first one is the parent one, which is y equals x squared. Square is here on the bottom. Okay? And second equation is y equals, let's see what the equation is. 2 parentheses minus 3 plus 1. So 2 parentheses x minus 3 square plus 1. So you see these two graphs. The one right in the middle is your parent graph. Okay. And you're gonna move your parent graph to reach your baby graph and see the corresponding movement. So from the parent, we're gonna move to the right side. How many units? 1, 2, 3 units. And then we're gonna move up 1 unit. So right 3, up 1. And you see what? You see the baby picture is thinner than your parent picture. So how can you make your parent thinner? You're gonna pull it this way. You're gonna pull it upward. So how do we describe pulling it upward? It is vertical stretch. So here we have 3 transformations. Vertical stretch for the 2 in the front. Go to the right 3 for the minus 3 inside. Go up 1 for the plus 1 outside in the equation. So these are your 3 answers. Okay. So let's put your answer down. So stretch, move to the right 3 units, and then move up 1 unit, and that's it. Okay. Next one. So here you have this more complicated baby equation. And you're gonna tell me what is the corresponding parent equation. So in the baby equation, you see the most basic part is x and absolute value. So the parent is absolute value of x. Okay. So now we're going to put both of the equations in the decimals and look for their difference. Okay. So this time our parent equation becomes y equals absolute value of x. And our baby equation becomes y equals negative 1/3 absolute value of x, let's see the equation, plus 2. See the equation. Yes, I'm right. Yeah. And now you see what? You see this is your parent equation, right in the middle, 0, 0. Okay? And from your parent to reach your baby, let's look for the changes on the graph. Okay. So first, from the parent to reach to the baby, we're gonna go up. How many units? 1, 2, 2 units. And then you see you reach your baby, right? And you see the baby picture is upside down compared to the parent picture. So how do I describe upside down? It is reflection. So that's the second transformation. And finally, you see what? You see compared to your parent picture, your baby picture is wider than your parent picture. So how do I describe wider? It is vertical compression. So these are the three part of the answers, three transformations: vertical compression, reflection, and going up 2 units. Okay. Reflection, the negative sign tells you reflection. The fraction number tells you compression, and add a number outside tells you going up. Okay. Next one. So here you have this more complicated baby equation. And from this, what is a parent equation? So the most basic part in the baby equation is square root of x. So your parent is y equals square of x. Now let's put both of the equations in the decimals. So this time the parent equation becomes y equals square root of x. And the baby equation becomes y equals square root x minus 4 inside and then plus 2 outside. Okay, so let's look at the changes on the graph. So this is a parent equation, parent picture. Okay? And this is a baby picture. So from your parent, go to reach your baby, look for the movement. Okay? So from the parent, I'm gonna move up 1, 2, 2 units up, and then move to the right 1, 2, 3, 4, 4 units to reach your baby picture. And you see the parent and the baby have the exact curve. It's not making it flatter or making it more curving, right? So there's no compression or stretch. So the only transformation is moving up 2 and move to the right 4 units. Minus 4 inside means move right 4. Plus 2 outside means move up 2 units. Okay. Next one. Which graph has the parent function? That is y equals x cubed. Okay, so here we're looking for the parent function. So first you have to know what does the picture look like for this parent function, cubic function. So we learned in the parent function class for y equals x cubed, the picture is always look like this, right in the middle as the origin. Okay, this is what the parent picture look like. Okay? And now you just need to tell me which one of these baby pictures have the same shape as this parent picture. We see B have the same shape, so your answer is B. Okay. Next one. So here you have a chart, and this is a property sales from year 2008 to year 2018. And the question is, what is the total sales amount for the year 2015? So first you have to look for the year 2015 on the x-axis, which is here. Okay. And now from this mark, you're gonna mark the year 2015 and then extend your mark to reach the point on the graph. So we're talking about this point. Now you're going to tell me what is the total amount on the y-axis for this point. So from this point, go to touch your y-axis, and you'll see we touch here, and the total amount is 15, 0, 0, 0, 0, 0, 0. Okay? So this is just like F 2015 equals what? Right? It's the same question as what we did before. Okay. Last one. Which year has the lowest sales amount? So you look at the sales amount and which year have the lowest sales amount. So on the graph, look for the lowest point there, as this point is corresponding to the lowest of sales amount. So what is the corresponding x value for this point? Which year on the x-axis? So go down from this point to touch x-axis. You'll see it touches 2011. So for the year 2011, the sales amount is the lowest. Okay. So that's it about the review for our first test.